Hey buddies, my name is Sibusiso, but you can also call me Coach Sbu. Welcome into the Maths Buddies tutorials. In this video, we're going to be going through our third topic of our March exam preparations, grade 12. In the previous two videos, we covered trigonometry, grade 12, and also we talked about sequence and series. Now in this video, we're going to be getting straight into functions. So let's jump right into the question. So here we're given question 5 and we have some instructions that we given there below. So let's go ahead and first read that, and then from there we're going to be explaining how you basically approach such questions. So let's go ahead and read the instruction there. So the diagram below shows the graphs of g of x is equal to 2 over x plus p plus q, and f of x is equal to log base 3x. Y is equal to minus 1 is a horizontal asymptote of g. B, which is 1 to 0, is an x-intercept of f. A, which is t to 1, is a point of intersection between the f and g. Then the vertical asymptote of g intersects the x-axis at E and the horizontal asymptote at D. OB is equals to BE. Alright, so here we are given these instructions and then we are given this diagram. So this is basically what we call interpretation. So interpretation, it means now we're going to be looking into this diagram and this instruction to find the equations of g and f, and to also answer, of course, other questions that they might ask us, right? So now, first thing now that you always need to do before you can actually answer your questions is to make sure that you identify the equations or the function that you're given there, and also take out their qualities or their characteristics, right? So for example, here we are given g of x is equals to 2 over x plus p plus q, right? So here this is a hyperbola, right? So I want to write it there, hyperbola. All right, so in a hyperbola, what are the important things that you must know? So the hyperbola, we have this value here, which is the value of a, right? So this value of a here, it is 2. So if it is positive, it means now the shape of the graph is going to be like that, right? Now as you can see here, we have that shape, as you can see there and there, right? Now the second thing that is very important is for you to understand this x plus p. So this x plus p, when you equate it with 0, right, it gives you the equation of a vertical asymptote, which is x is equals to minus p. What about this one here? With this one, the same is true. When you equate this one with q, so this value of q, when you equate it with y, it gives you what you call a horizontal asymptote. So we know that here we have our horizontal asymptote, and then here we have our vertical asymptote. So that is the first part about the hyperbola. And the second part, it is the equation log base 3x, right? Now this one is called a logarithm, right? Logarithm, or you can call it a logarithmic function, right? Now with logarithm, how they work is that this is an inverse, right? This is an inverse of an exponential, right? But it is also a function. But then now the reason why I'm saying it is an inverse of an exponential is because most of the time when you're given a logarithmic as a question, they will always ask you to find its inverse, which is going to be the exponential. So which means now in order for you to actually find that, you must understand the equation that these two graphs they do, right? So let's go ahead and first explain something about the exponential, right? So in exponents, right, if you're given an equation like so, a is equals to y is equals to a to the power of x, we know that this value here and this value here and that value there, they have a name, right? Now this one here, a, is called the base, right? And then this one here, we call it the power, right? And then this one, we like to call it like a solution, or you can just call it a constant, right? So I like to call it a constant. The reason why I'm calling it a constant is because most of the time this is the answer that you get after you have actually generated your exponent, right? Now the idea here is that if you want to change, or if you're given an exponential and you want to find an inverse of an exponential, we know that it's going to be a log. But now sometimes people they tend to make mistakes when they're actually doing that. So now here I have come up with a formula that can actually help you so that you can basically identify how this thing works, right? Now with that formula, how it works, it goes like this, right? So I'm going to be writing it in words. For example, here I can see that I want to have an exponential, so it means here I have the constant, right, equals to the base, right, into the power, right? Now the formula that we use is that if you want to take an exponent and then you're taking it into a log, the formula there that you're going to use for the log, it is going to be power, right? Power, it is equals to log base and your constant. So this formula, it has worked throughout like the entire time whenever I've actually struggling to find an inverse. This has helped me to actually identify how it works. So now notice that here, this part that is on your left, it is an exponential, right? And then that is a log. So you can do this this formula and vice versa. For example, if you're given a log and then they want you to find an inverse, it means you're gonna you know that this whatever value that is there is gonna be your power, whatever value whatever value that's gonna be there, it's gonna be your base, and whatever value that's gonna be there is gonna be a constant. And then if it was an exponential, then now you're taking it to log. You know that whatever value is gonna be there is gonna be a constant, and then it's gonna be a base, and then there is gonna be a power. But you're gonna see this one when you actually do it, right? So now with that being said, let's go ahead and actually go into our question, right? So this was just me adding information, but then here, this is where you had to actually understand first, identifying what is happening so that you can understand what you're given there. So let's go ahead and go into the first question now. So the 5.1 here, it says let's write down the range of G, right? Now what is a range? So a range is basically where the graph is sketched on the y-axis, right? Or the y values where your graph is sketched, right? So now with the hyperbola, we know that all the values of the hyperbola, right? This is where your graph is sketched, but except for the value that is going to be your horizontal asymptote. So it means now here we know that we have our horizontal asymptote, which is -1. So which means now we're going to say such that y is not equals to -1. Now when you read this, it means all the y values, right? You have our hyperbola being sketched, but then now the one that we don't actually sketch our hyperbola on is your horizontal asymptote. So y is not equals to a. So I'm going to write that as the horizontal asymptote. Okay. So now the second part here, they want us to find the equation of g. So now g of x, we know that this is 2 over x plus p plus q. Now here from the diagram, we were told that y is equals to minus a is a horizontal asymptote. So which means, if you remember previously, we said that this value for q, it is the same as your horizontal asymptote. So which means now here, because of I'm given a horizontal asymptote, I'm going to start by saying y is equals to q, right? And then I know that the y value for that horizontal asymptote, it is what? It is -1. So it means now here I'm going to say -1 is the value for q. Now after having that, I'm going to then update my equation because that's what I just got now. So I have x plus p minus 1, right? And then now the next question now here, it says I need to actually find the value for p, right? Because now that's where I need to actually finish my my graph, right? So to finish my graph with that value of p, what I'm going to do here, there's actually two things that I can do. I can firstly either take this point that b has, because oh sorry, this point it is for the exponential. So what I'm going to do here is I'm gonna go back into the instruction that I'm given, right? Remember in the instruction we were told that OB is equals to BE. So what that meant is that the distance from here to there is the same from there to there, right? Then notice that this point here, it is where we have our vertical asymptote. So which means now here, to get the value for P, what I'm going to do here is I'm going to say that I need to find the x coordinate of E, and the x coordinate of E is going to be 1 plus 1, which gives me 2. Now why am I saying 1 plus 1? Because from O to B, I know that it is the x value there, it is 1, right? So it means this distance is 1 unit. And then now if I have another unit which is 1, add them together, it's going to give me 2 units, and then this will mean now this is going to be 2:0, right? So hence I have my x coordinate of E as 2. But then now I know that this x coordinate is the same as the vertical asymptote, right? So now I'm going to say it now on my vertical asymptote. I know that x is equals to minus p. And then now this x coordinate is the equation of the vertical asymptote. So which means now I'm going to say 2 is equals to minus p divided by minus 1 divided by minus 1. And therefore the value of p is going to be minus 2. And so my equation here is going to be g of x is equal to 2 over x minus 2 minus 1. And that is how we get our value. Okay, now let's go to 5.3. So 5.3 says let's find the value of t. So now my equation, remember, it is 2 over x minus 2 minus 1. So now here t is the point that is on either g or f, right? So I can take either of those equations to solve that point there, right? So now to make it more interesting, right, I want to let's take the equation of the exponential of the logarithmic, right, and see how we can solve our value t, right? So what I'm going to do is, instead of taking this one, right, I'll take the other equation. So let me take f of x is equals to log base 3 x, right? Okay, so now here I know that point for a, it is t is to 1. So I'm going to substitute that. So when I do that, I'm going to have 1 here equals to log base 3t. All right. Now here, let's say now I want to solve for this, right? So I wanted to, the reason why I'm using this one is because I wanted to actually take you back into what I wrote earlier on about exponents and logs, right? So now here, I want to solve this value here. So if I want to solve this value, I need to ask myself, what do I call this one, right? So it means I'm going to go back to what I wrote there. And then if you remember here, this value on logs is called a constant. So it means if I want to solve for a constant, this is the formula that I'm going to write. So the formula that I'm going to write is going to say constant equals to base power, right? So now in my equation there, I know that this is the constant. I know that this is the base. I know that this is the power. Why? Because that's what I get when I have a log, right? So therefore, to calculate the constant, therefore to get the constant, I'm gonna say base into the power, right? So what's my constant here? It is t. What is my base? It is 3. What is my power? It is 1, and therefore t is equals to 3. Now this value, you're gonna get it even if you would have used the hyperbola, but I just wanted to show you how easy this thing becomes when you actually do the formula that I've given you there. All right, so now let's look at 5.4. 5.4. So now it says here 5.4 says write down the equation of f inverse, which is the inverse of f in the form of y. All right, so now here they want us to calculate the inverse. Okay, so now to calculate the inverse, the first thing that you're going to do is we're going to take the equation of f. So f, it is y equals to log base 3 x, right? Remember, we want to find the inverse of this. So by getting an inverse, it means we want to solve for x, right? What is x? X is your constant. So now, according to the formula, we know that the formula says that if I have here power equals to log base constant, when I want to find the constant, I'm going to use the formula which states that constant, it is base into power, right? So now here I already have this one, which is this. So now I just need to write that now, right? So now here, therefore, my constant is going to be x equals to my base is going to be 3, and then the power is going to be y, right? Then now here you see that I have solved for x, and then after solving for x, what I'm going to do, I'm going to change now the x variable into a y variable, and then the y variable into the x variable, and that is how we get our value. All right, now here 5.5 states that for which values of x will f inverse of x be less than 3, right? So basically here, what's happening here now is that they're asking us about an inverse, whereas we have actually in our sketch we are given our normal graph, right? Now in order for you to understand this, you have to think about it as how everything looks like, right? So let's go ahead and picture this firstly. So now here we know that the easy way to actually do this is to first write the inverse x less than 3, right? So now we know that here the inverse here, it is not part of the diagram here. Now because of it is not part of the diagram, it means that the easy way to approach this, it is by actually writing the formula for the inverse, right? Now what's the formula for the inverse? The formula for the inverse is 3 to the power of x. Now this is less than 3, right? Now here we see that 3 to the power of x less than 3 to the power 1, inequality. So this can also be that if x it is less than 1. Remember on the exponential equations, so the same is true when it comes to what? When it comes to inequalities. So that is how we basically get our value. Now the last question here, right, it is going to be determine the point of intersection of the graph of f and the axis of symmetry that has a negative gradient. All right, so now here basically in 5.6, let me write this. So in 5.6 we are told that they want us to find the point of intersection, right, of f and the axis of symmetry of g that has a negative gradient. So now firstly we know what f is, right? We know that f is y equals to log base 3x, right? So now here we need to also have what we call an axis of symmetry. So what is an axis of symmetry? So an axis of symmetry on hyperbolas is a line that divides the hyperbola into two equal halves, right? So now here to get the axis of symmetry that has a negative gradient. So with the negative gradient, I'll say gradient less than 0. We're going to have the formula, let's say y is equals to minus x plus p plus q, right? So that's the formula that we're going to be using. Now here the x plus p comes from the formula there, and then this q comes there, right? So the x plus p, we know that here our x plus p became x minus 2, right? When we're solving the, so this was on 5.2, right? And then the value for q, it became minus 1. So basically we will first solve our equation like that, and then we will have our equation there, right? So now here basically they want us to find the point of intersection of this equation and that equation. Now according to the scope that you guys have, the grade 12 have, right, there is no way that you can find the x value where this is equal to that by solving this, right? There is no way, which means now here what we need to do is we need to interpret, right? So now when we interpreting, we first need to ask ourselves where does this line of symmetry lie, right? So this line of symmetry lies in somewhere there, right? So if I'm drawing it, it lies in somewhere there. Let me just try by all means to make sure that it cuts there. Now notice something here as I'm drawing this line. Notice something that here when I'm drawing this line, it touches the exponential right there, right? So it touches this exponential when at the point B, which is 1 to 0, right? So now it means now here, without me solving this, the easy way that I can actually prove that there is a point of intersection here is if I can prove if this point here, which is 1 to 0, is also the point of what? Of the axis of symmetry. Now how do I do that? So I do that by saying let x to be equals to 1, right? So why am I saying x is equals to 1? I'm taking the x coordinate of that point there, which is b, right? So now if I'm taking this coordinate and I'm substituting it in this equation and then it gives me 0, it means now b is also on that line of symmetry, right? So now here I have minus 1 plus 1. As you can see there, I'm getting 0. So therefore it means b, which is 1 is to 0, is the point of intersection, right, of f and the line of symmetry, right? And that is basically how you answer this type of questions. And that is all for this video. Again, if you like the video, please make sure that you can share this with your friends. This is just to help you to prepare for your March exam preparations, and I'm going to leave it to you like that. And also please make it your mission to make sure that you make your friends' life better, or your friends' maths life better. And I appreciate you, and I hope you have an amazing day. Cheers.